Hello everyone, welcome to the second video in my DC20 math series. Today we're going to be talking about advantage and advantage math. Now you may have seen videos like this around the internet because they're relatively common. In fact, this is going to be a little bit of a probability refresher, so stick with me. If you already know how to work with some basic probabilities, you can skip further in the video. There are timestamps. Alright, so let's talk about what advantage is first. Advantage is rolling two d20s and using the highest result. So if I roll a 17 and a 15, then the overall result is just a 17, the higher result. You'll sometimes see advantage abbreviated as ADV, shown above. That's just a shorthand that makes it easier to recognize in the book. Similarly, we can talk about disadvantage. Disadvantage is when you take 2d20 and use the lowest result. And this, similar to advantage, has its own shorthand, which is this dis and then ADV for advantage. This shows that it's the disadvantage. So these two are pretty similar. You roll two dice and sometimes multiple dice, and then you're going to use the lowest or highest result, depending on whether you have disadvantage or advantage. So let's talk a little bit about probability. And for this, I want to talk a bit about timelines. I want you to imagine that when we're discussing probability, we're talking about a bunch of different possible timelines and the probability of each timeline to occur. So let's start with the basic probability scenario. What's the chance to roll heads twice with two coin flips? So here I have the basic probability that most people are familiar with. I flip a coin and I can get heads or tails. There is a 50-50 chance of getting either one. Now, because I'm working with probabilities and I'm going to want to do math with them, I'm going to represent that as a decimal. So in this case, 0.5 chance to get heads and a 0.5 chance to get tails. So now we've created two separate timelines, the timeline where I roll heads on the first flip and the timeline where I roll tails on the first flip. Within each of these timelines, another flip is happening. And so within each of these timelines, there is another 50-50 chance to get heads or tails. So now we can see basically all the possible timelines. In the end, there are four possible timelines. I could roll heads and then heads, heads and then tails. I could roll tails and then heads, or tails and then tails. So how can I get heads twice? Well, there's only one possible timeline where I can get heads two times. I need to get heads the first time and heads the second time. This means there's a 0.5 chance that the first instance takes effect, and then another 0.5 chance that it'll happen again, right? That I'm following the correct timeline all the way through. And so if I wanted to appropriately do the math with this, I'm going to multiply these probabilities. I take that 0.5 chance for the first event to happen and a 0.5 chance for that second event to happen based on that first one. And overall, we end up with a 0.25 or 25% chance that I'm going to roll heads two times. Okay, this is a little bit basic. Let's talk about another basic probability question, still thinking just about flipping coins. What's the chance to roll at least one heads with two coin flips? Okay, so same starting scenario. I flip my coin, there's a 50-50 chance either way. It could be heads or tails. And then I flip another coin, and there's a 50-50 chance either way, heads or tails. So in this case, what's the chance that I get at least one heads? So looking through all of my possible timelines, there are three timelines in which I roll heads. There's the one where I roll heads twice, the one where I roll heads and then tails, the one where I roll tails and then heads. There's basically just one timeline where I don't roll heads at least one time. And that's going to be the time that I roll tails two times. So while I could think about adding up all the chances that I roll one heads and think about what's the chance that I'm ending up in any of these three timelines, I can really think about this as a separate question. The question I'm also asking here is, what's the probability that I don't roll heads two times? So there's this timeline where I roll heads two times, and there's a 0.5 chance I roll that I roll tails two times. There's a 0.5 chance I roll tails the first time, and there's a 0.5 chance I roll tails the second time. And I want any timeline that's not that, right? I want the 100% chance that I'm in some timeline, except for that chance that I'm in this one cursed timeline that I don't want. And so what we can do is we can take the probability to be in any timeline, 100% chance, and remove from that the probability that I'm in the tails timeline. And that's going to be that same sort of math as the timeline of before, right? That 0.5 chance that I roll tails, that I flip tails the first time, and a 0.5 chance that I flip tails the second time. So that's 1 minus 0.25, or overall a 0.75 or 75% chance. So these two basic situations are actually going to help us understand how we can do math with advantage and disadvantage. In fact, let's think about the logic behind advantage for a moment. See, disadvantage is just asking us what's the chance to roll the result both times, pretty much like that situation where we're trying to flip a coin and get heads both times. Whereas advantage is saying what's the chance to roll the result at least once, basically telling us the same situation as when we're trying to flip the coin and get heads at least one time. These two situations of disadvantage and advantage match up to these two coin situations I talked about earlier. Okay, so let's start with the disadvantage math, because it's actually a little bit easier. So let's think about this a little bit like the coin scenario, except this time, instead of a coin flipping and having heads or tails, we're going to represent a roll on the dice, and that roll could either result in a hit or a miss. Now, of course, we're talking about advantage and disadvantage here, so there's going to be a true hit and miss chance based on the overall chance of rolling the two dice and then choosing the lowest. But in this case, I'm using the word hit chance to say, if I just rolled one dice, would it count as a hit or would it not? So in this case, I'm using a number. Let's say I have a 65% chance of hitting the target, right? There's the 65% of my dice rolls could result in me hitting the target, and 35 are not, right? Assuming I was just rolling a regular roll with no advantage or disadvantage. So there's this first scenario where there's 65.65 right chance to get the hit, and then a 0.35 chance to get a miss. And then, of course, I roll a second dice and the second die, and now I have that chance repeated, a 0.65 chance to get hit and a 0.35 chance to miss in both of these scenarios. So what's the chance I'm going to hit with disadvantage? Well, I basically need to make sure that both of these rolls are going to hit. I need to make sure that I'm always going to get the same result, and it's a hitting result. And so just like flipping the coin twice and wanting heads both times, here I'm going to want to roll the dice twice and get a hit both times. And so that's going to be represented by this timeline here, where I roll heads, or really I get a hit the first time, and I roll heads or get a hit the second time. And in this case, it would just be the 0.65 times the other 0.65 to get me an overall chance of 0.4225, or if you like thinking in percents, a 42.25% chance. So we can see that my chance originally should have been 65% chance. It's now dropped down overall to a 42.25% chance. So disadvantage made it harder for me to hit. Okay, let's think about this more generically. Let's remove the number 0.65 and just use the words hit and miss, right? Or H and M here. Well, my true hit chance, right, the hit chance I actually have because of my disadvantage, is going to be my hit chance times that hit chance, or really just the hit chance squared. All right, so let me talk about this with some nicer, cleanly laid out equations with that hit chance we talked about in the DC20 attack math video. If you haven't seen that, you should go to watch it. But here's our chance to hit, right? Our hit chance is going to be 21 plus the attack check we have minus the defense divided by 20. And so the true hit chance, the chance that we're actually going to hit with disadvantage, is going to be that number, 21 plus the attack check minus the defense over 20, squared, right? We're multiplying that whole result to itself, right? Okay, so here's disadvantage cleanly laid out. Let's switch over and talk about advantage. Same thing, right? I'm talking about the chance to hit and my chance to miss. So let's start with the same scenario as before. There's a 65% chance I'll hit normally and a 35% chance I'll miss. So a 0.65 and a 0.35. I roll the first roll and then I roll the second roll. So if I want to hit with advantage, I need to make sure at least one of the rolls can hit. So essentially, I need to end up in one of these three timelines where at least one of the rolls is going to end up being enough for me to hit. And essentially, I want to avoid this one timeline where both of the rolls are not going to let me hit. So just like the coin flip scenario initially where we needed to roll at least one heads, this is the same thing, except we need to roll at least one hit. And this is going to result in a similar math where we have 1 minus the miss chance times the miss chance, so 1 minus 0.35 times 0.35, which is 1 minus 0.1225, and overall that's going to be a 0.8775 or 87.75% chance. So you can see here, advantage brought our hit chance up from a 65% chance to hit to an 87.75% chance to hit. All right, thinking about this with just our hit and miss, that means we need to end up with this in any of these three good timelines, avoiding this one bad timeline, and that's going to be 1 minus the miss chance times the miss chance, which is equal to 1 minus the miss chance squared. So laying this out with some equations, here we have the hit chance, that's 21 plus the attack check minus the defense over 20. Our miss chance is just 1 minus that hit chance. And so our true hit chance, the one that we're going to have with the advantage, is going to be 1 minus that miss chance squared. It looks really complicated laid out like this, but when you start putting in the actual numbers, it starts to simplify out really quickly. And so overall, we're just subtracting the normal miss chance, we're just squaring the normal miss chance, and then subtracting it from 1. All right, so here's my basic summary laid out. This is all the three of the equations for our disadvantage chance, our hit chance, and our advantage chance. But in DC20, things aren't that simple, because you can stack your advantage. You can have advantage X or disadvantage X, where you roll that many dice, or you roll really one more dice than that, and then choose the highest. So if I have disadvantage 3, that means I have disadvantage and then another disadvantage and another disadvantage, which means I'm rolling 4 dice and choosing the lowest. For each level of disadvantage, I'm adding an additional dice and rolling and then choosing the lowest. So with disadvantage, the regular amount, I roll 2 dice and choose the lowest. I've added only 1. With disadvantage 2, I'm rolling 3 dice and choosing the lowest. I've added 2 dice. The same logic goes for advantage. If I advantage 2, that means I'm rolling 3 dice and choosing the highest. So the logic is pretty similar. With disadvantage, we basically need the chance to roll the result every time. And with advantage, we need the chance to roll the result at least one time. So let's flip this back and go to a disadvantage, but thinking about the stacking logic. Essentially, all we need to change here is that every time we need to multiply by that chance to roll that over and over again, right? If I'm rolling 4 dice, I now need to continue down those timelines where I continue to not roll, to continue to roll the good roll, right? And the hitting roll. And in this case, that's going to be our same hit chance, but now instead of squaring it, we're going to have it to the power of x plus 1, where x is a disadvantage x amount. So if I have disadvantage 2, that means it's going to be to the 3rd power. And this is really because we're rolling that many dice, right? I have 3 dice I'm rolling, and so the other way you can think about it is the power that I'm raising it to is just the amount of dice that I'm rolling. If I'm rolling 2 dice and choosing the highest, I put it to the power of 2, which is what we did when we used the disadvantage. Disadvantage was just squared, which is the power of 2. If I'm rolling 3 dice and choosing the lowest, it's to the power of 3, and so on and so forth. So the same kind of thing applies to advantage. If I have stacking advantage, well then I'm going to change my formula from before, but instead of squaring that, mischance, I'm instead going to raise it to the power of x plus 1, right? Or really I'm going to raise it to the power of the amount of dice that I'm rolling. So if I'm rolling 4 dice, then I'm raising that mischance to the power of 4, and then subtracting that from 1. Okay. And this is the overall summary of stacking advantage and stacking disadvantage. If I have disadvantage x or advantage x, we can use these formulas to find out what the overall chance to hit or miss is. Again, if you would rather think about rolling the dice and how many dice there are, rather than the level of advantage or disadvantage, just put the amount of dice instead of x plus 1, right? If just have y be the amount of dice you're rolling, and just put that in there in the exponent. Okay, so wrapping this up, let's relate this to the damage calculations from the last video. Nothing really changes that fundamentally from the math that we did in the last video. In fact, this is a modified slide from my last video, and really you can see that the only thing that matters is that we just have to replace the hit chance, heavy chance, brutal chance, and crit chance with the matching chances that you would actually have with advantage or disadvantage. So rather than the hit chance being the one with 21 plus the attack check minus the defense over 20, we're instead going to just replace it with whatever it should be with the levels of advantage that we have or the levels of disadvantage that we have. And we go through and replace that for each of those chances, including the crit chance. Remember that your chance to roll a critical hit does change when you get advantage or disadvantage. It's actually one of the main benefits of rolling advantage and one of the biggest drawbacks of rolling with disadvantage. All right, and that is everything I wanted to cover with the advantage video. I wanted to keep this one relatively short and to the point. There are plenty of videos out there if you want to get a better idea of advantage and disadvantage and the math of rolling multiple dice, but I wanted to keep this very much on topic for DC20. Thank you so much for watching, and until the next time, have the best time.